Hi, welcome back to my statistics class. So today we'll continue to talk about confidence interval. So now in this chapter we're going to talk about how we're going to make a conclusion and also finding the critical z-score. Okay, so remember our fishnet. So in the last example we have a 95% of confidence interval which is 0.4604 to 0.4996. This is our 95% of confidence interval. But this is the confidence interval for the population proportion. P, not for p hat. Okay, so remember this part is our lower bound. You can consider that is the edge of the fish head we want to use to have the 95% of chance to catch our fish. Not fish head, fish net. And this is the upper bound. And then for the wording, we have three things we need to be including. First, the level of confidence. That means what kind of fish net that you're going to use. Do you want to use a bigger one, which you will have a higher chance to catch the fish, which is 95% of confidence interval, or 99% of confidence of interval? Or you want to use a smaller fish net, which is maybe 80% of the chance to catch the fish. Second is the range of the value. That means we're trying to find out how big the fish net is. So that means we need to calculate the upper bound and the lower bound. And the third part is you need to describe this is related to a population proportion. We're trying to catch the fish, not the estimate of the fish. So that means related to all of the data or all of the population. So we should never mention about the sample. Never mention about the sample proportion. P hat. Okay, so now let's see, can we make the conclusion like the following sentences? Is that correct? So it says 48% of all the HR professionals use social networking site to research job applicant. So it gives you what? This part gives you a proportion, right? P of all the HR proportion. So this gives you 48% is actually the p hat, the sampling proportion, not the population proportion. So remember that p hat is the estimate of the population proportion. Remember that whenever we mention about the p hat, that means this is wrong. We can't make a conclusion like that. So you need to remember that sometimes the sampling proportion will equals to population proportion, but not necessary. So remember when it's not necessary, when they doesn't pass the success or failure rate or doesn't pass the central limit theorem conditions. Population proportion. Okay, now let's look at B. It is probability true that 48% of all HR professionals using social networking site to research the job applicants. Again, 48%. That means they're still using the sample proportion. Remember that we can, in the conclusion, we can mention about the sample proportion. Okay, so now we can use this one. So C, we don't know exactly what proportion of all the HR professional, which is good. This is good because we don't exactly know. Using social networking site to search job applicant, but we know that that's between 48% and 58%. Okay, so what do we have? Let's see, do they missing all of that? We have level of confidence, range of values, description of the population proportion. Okay, so we have number 3, right? They do describe the population proportion. However, and also they mention the range, which is they satisfy the second one. But which part we're missing? They're missing the level of confidence. How confident you jump into this conclusion. So that means this is also no, because they're missing the level of confidence. Okay, D, they say we don't know exactly what proportion of all HR professional use social networking site to search job applicant. This is good, but it's probably between 46 and 50. So, okay, so this is basically is similar to what we have for number C. They're missing the confidence interval. Also, there's another catch in here, but we don't know. We never know. If they say we know, basically they tells you that, hey, this is 100% sure. But we don't want to do that. We want to be accurate. We never say 100% sure that this is between what and what. So this part also missing the confidence level. So we can use that. The level of confidence. So it's a no. Okay, now let's look at E. So we are 95% of confident that, okay, we have confidence interval, check, between 46 to 50%, which is the range of a value. We check that part as well. And then what? Of all the HR professional, all tells you what? The population proportion, which is check. So that means we can use these sentences, this type of sentence of conclusion to make a conclusion. Yes. So look, you need to have all these 3 conditions. All of this information to include in your conclusion. 1 is confidence of interval. 2nd is the range of value. 3 is the description of the population proportion, which means you need to mention all. Okay, so now next is how do we find the confidence interval, or how to identify the z-score. The easier way to do it is we use a standard normal distribution, whereas the center is 0. And then in order to attain 99% of the value, so in the middle is 99%, we need to find out, hey, what will be the cutoff value for the left tail and the right tail. So the shady area should be what? Since the middle part is 99%, that means the 2n is going to be 1%. So that means each n would be 0.5%. Or you convert it into a decimal. This is 0.05. Okay, now let's use GeoGebra. So we have a mu equals to 0 and standard deviation is equals to 1. And then we want this to be 0.05. So the upper bound is going to be what? 2.5758. And now let's find the lower bound. So again, since it's symmetric, the lower bound should be the same, but should be negative. So again, we're trying to find the 0.5% of the left area. So look, is going to be a negative 2.57583. So that means the z-score is going to be positive or negative 2.5758. Let's just keep rounded to 4 decimal places. So similarly to 95% of confidence interval, again, we want the middle part. We want to use the standard normalized distribution because that's the easiest one. The center is going to be 0. Each standard deviation would be 1, positive and negative 1, and then 2, positive and negative 2. So again, we want the middle part to be what? 95%. So that means these two tail, the sum of these two tail is going to be 5% because they're symmetric. So that means you divide it by 2, each part of this is going to be 2.5%. And now we're trying to find the cutoff value. GeoGebra. So we want this to be 0.25 now. So on the left, we have what? The cutoff value is going to be negative 1.9599, which is approximately negative 1.96. And then let's look at the right side. Again, it's symmetric, so there should be the positive value of it, which is the cutoff value should be positive 1.96. So now the z-score of here should be 1.96, positive and negative. Positive means the upper bound, the negative means the lower bound. Okay, 19% of confidence of interval. Again, the idea is the same. So I would suggest you to pause the video and try to do it by yourself and trying to find the cutoff value. We want this part to be 19%, so do it by yourself. Okay, did you find the cutoff value? So these two parts you want it to be what? Since the sum of these two ends equals to 10%, so each part should be 5%. So we know that it's symmetric. That means if we found one side, the cutoff value, then we can identify the other side. So now let's do that. We want it to be 5%. So the cutoff value should be 1.6449. So that means to the left would be negative 1.6449. So our z-score should be positive or negative 1.6449. Okay, so what about 80% of confidence interval? Again, try to do it by yourself. So the center would be 0, and we want the middle part would be 80% of the value. So that means this 2n is going to be 10% for each. And now let's find the cutoff value. So since the 10% should be 0.1, this is equal to what? 1.2816. So to the left side should be negative 1.2816. So the z value, the z score or the critical score is 1.2816. Okay. So in the next class, I'll give you more examples about how to construct a confidence interval. I'll see you next time.